Good afternoon, PMLS Tigers. Today we're going to be working with graphing absolute value equations. You can use the book as a reference in section 6.8, so just know that that is available to you. Today our I can statements are, I can explain that the parent function for an absolute value function is the function of x is equal to the absolute value of x. Also today we're going to be concentrating on graphing from the vertex of the absolute function, where the vertex is located at point HK with the value of A describing width. So we'll be referring to that today. An absolute value equation is a V-shaped graph that points upwards or downwards. So far, we've worked with parabolas, which were quadratics, and those were also facing upwards or downwards. There's going to be a lot of similarities on graphing a quadratic versus graphing an absolute value function. You're going to see that the difference will be the absolute value bars as opposed to parentheses. A translation is a shift of the graph either horizontally or vertically or both from the parent function. So take a look at this graph. I know this graph isn't on your paper, so you can go ahead and just sketch that on your slide. The parent function is y is equal to the absolute value of x. And so what you're looking at here is the parent function. It should be no surprise to you that the parent function starts at the vertex and travels at a rate of 1, 1, either direction, so up 1 and over 1, and there is no shift, so it just stays right there at the point 0, 0. When we get into more complicated equations, then we're going to use this formula, which once again should look very similar to what we used with quadratics or parabolas. If the equation is in the form y is equal to the absolute value of x plus 4, the graph moves. So this is what we have to figure out. If you think about substituting in for the absolute value of x, we want that value within the absolute value bars. We want that to be a 0. Well, the only way to get there is to substitute in the number 0 for x. So the absolute value of 0 is 0. 0 plus 4 is going to give us 0, 4. So if I'm at 0, 0 and I go up 1, 2, 3, 4, then I'm going to shift vertically. Vertically means up or down. So that means up or down. And we're going to shift up. It would be 4 units up is how we would shift on that. So we're going to say 4 units up. So looking at the second equation, now we have y is equal to the absolute value of x plus 4. So we know that this is our k. So the k is going to be the shift of our y, where when we're inside the absolute value, we're talking about h. And we know that the original formula was x minus h. You guys have done this before. So x minus h is going to be x minus a negative 4. So that's one way to think of it. What I always think of is within the absolute value, what would I have to substitute in for x to make that value 0? So the opposite of a positive 4 is going to be a negative 4. So then our point would be negative 4, 0. So in other words, I'm kind of getting writing all over my stuff here. So if I were to substitute in negative 4 here, then I would have negative 4 plus 4, or the absolute value of 0. So my input is negative 4, and my output, or y, would be 0. So that coordinate, we're going to concentrate on the vertex. The vertex is always going to be a point. So the shift then here would go 1, 2, 3, 4. So it would be at negative 4, 0. So that's going to be moving horizontally. And instead of up or down, you may have guessed it, we're going to shift left or right. So if we're going to shift up or down, so just going to add another little symbol here. Up, of course, is going to be positive, and then down is going to be negative. If it's left, we're going to shift negative, and right is going to be positive. So remember again, because we're going to talk about this again, this is our parent function. The parent function is, notice the direction that is facing upwards. So within our equation, here's the parent function. You may not have seen that on here as well. If you notice outside of the absolute value right here in front, we call that the A term. The A term, there is no number, so that means it's going to be a positive 1. So because we have a positive 1, just like with quadratics, then it's going to be facing upward. All right, now for graphing. Every time we've graphed, we've kind of started off using a table of values so that we understand that it is an input-output kind of thing. This equation isn't even equal to y, so we need to make it equal to y. To do that, I'm just going to move the -8 to the other side of the equation. That means it's going to be y is equal to the absolute value of x, and that's going to be a +8. The first thing that I always want you to do is to identify the vertex. So to do that, I'm going to draw my table of values because we're going to need that here in just a second. In order to do that, then I'm going to substitute in, think about what you have to substitute in for the absolute value bars to make it a 0. Well, the only thing I can substitute in is 0. And when I substitute in 0 for x, the absolute value of 0 is 0. And then 0 plus 8 gives me my y. So we're just using a table of values to get there. So what I'm going to do, and we did this with quadratics as well, is I'm going to come down just a little bit. And I'm going to do 0, 8 here, and I'm going to put an asterisk by it, which would represent our vertex. And then I'm going to choose numbers on either side in order to get more points. I'm going to do 5 points or so. So I'm going to do a -1 here and a -2, and then you may have guessed it, a 1 and a 2 there. So now we just go back and substitute in. When I substitute in a -1, the absolute value of -1 is 1. 1 plus 8 gives me 9. Now I'm going to do my -2 here. So -2. The absolute value of -2 is +2, because remember the absolute value means the distance from 0 on the number line, and so then 2 plus 8 is 10. And we should expect these numbers to match. And so when I had a -1, I got 9, so that should be a 9 there. And then when I plugged in -2, I had a 10. So that should match, and that's kind of a good indication that we've done this correctly. And we have, of course. So when I substitute in 1, the absolute value of 1 is 1, plus 8 is 9, and then 2 plus 8 is going to give me 10. So from there, then I can do a little graph action. So we're going to come here to 0, 8. 1, 2, 3, 4, 5, 6, 7, 8. And then I know I'm going to be almost off the table, aren't I? Okay, so 1, 9. Oh, let me come back here. -2, 10. All the way up here. -1, 9. So we just made it right just in time there. We're almost off the chart. And then 1, 9, and then 2, 10. So you can, with the parabola, you just kind of did curves and you made it a U. With this, we actually can use our straight edge, and you would be expected to do that. So from the vertex, we're going to come up and then there. And then I'm going to put arrows at either end. So we have successfully graphed our first equation. All right, our second equation. The function of x is equal to the absolute value of x plus 3. So we need our table of values. And I'm going to put my vertex in the center. In order to make the absolute value bars, we want to make that value 0. We know that the original equation was x minus h. So we're thinking of what the value of h is, but this is a plus. So to get there, it would have been a -3. That's another way to get there. So then my vertex is going to be -3. -3 plus 3 gives me 0. So there's my vertex. And then I can take numbers on either side. So I'm going to do -2, -1 here. And I'm going to do oops, I want to go keep it in numerical order. So I'm going to do -5, -4, excuse me, and then -2, -1 here. It doesn't make any difference, but I just like to keep my numbers organized. When I put in -5 for x, then that's going to be -5 plus 3. Just remember, we treat the absolute value bars just like we would a grouping symbol. So we treat it just like we would parentheses. In other words, I'm going to do -5 plus 3, which is -2, and then the absolute value of -2 is +2. So that's your thought process. When I substitute in -4, then I have a -1. The absolute value of -1 is +1. And like I said earlier, we should expect those numbers to match. So let's make sure that that works. -2 plus 3 is 1, and then 1, the absolute value of 1 is 1. -1 plus 3 is 2, and the absolute value of 2 is 2. So we did a great job. Now we can go over here. Negative 3, 0 is my vertex. And then I'm going to graph my points. So 1, 2, 3, 4, and then up 1. Negative 5, 2. And it should be a mirror image. So we've got negative 2, 1, and negative 1, 2. Looks like we did an awesome job. Again, make sure you're using your straight edge. Something else to recognize, we talked about this at the beginning of this show, is that, I said show. Huh, it is kind of a show, isn't it? In the beginning or right there in front of the absolute value, that's the A, and there is no number there, so we assume that that's just a positive 1. So I'm mentioning that because you'll notice that the direction of the graph that it does open upward. All right. Now we're just going to talk a little bit about some shifting. So what I would suggest to do is always identify the vertex first. Remember that the vertex is going to be the point HK. So that's something for you to consider. The original formula, once again, is y is equal to a times the absolute value x minus hk. Or if we talk about the parent function, it's just y is equal to the absolute value of x. So let's look at this and kind of break it down. The first thing I would do, like I said, is I'm going to describe my shift, but I like to have my vertex, and then that makes it a little easier to do that. So I know that within my absolute values, I need this value to be a 0. So the only way to get there is to put a 0. The absolute value of 0 is 0. 0 plus 9 gives me 9. So that's one way to look at it. I just kind of did my input output, but also h is our value, which has to be a 0, and then 9 is going to be our k or our y. So there you have it for there. So you can think about this as x and y also. So once I have the vertex, it's going to be easy. I know that if I was going to plot the point 0, 9, then of course I'm going to move up 9 units. So this tells me then that it is a vertical shift 9 units up. Now let's do one that's similar but also different. Whoops. You guys, oh no, that's good. I guess it didn't copy. Oh, here it is. It's all in my, sorry, I'm getting kind of crazy with my writing. Let me go over here. I see it on my notes, but I couldn't see it on your paper. So yes, the one that would be similar then is our x plus 9. So we're going to think of it as our h and k again. And so what I noticed is that here's my h. Well, it says positive 9. Well, remember the original formula is x minus h. So we have a y is equal to x minus h. And then plus your k. So then my h has to be the opposite of that. I like to think of it as whatever I substitute in there to make it a 0. So you may have guessed it. Then that's going to be my x is negative 9. And then there is no shift there. So that's going to be 0. Or input output. If I put in a negative 9, the value is 0. 0 plus nothing is still 0. So if my vertex, there's my b, is negative 9, 0, then what is the A, or what is the shift? Well, then if I'm moving to negative 9, then I'm going to be moving 9 units to the left. So once again, this is going to give you a horizontal shift. I'm sorry, vertical, which is up and down, where this is going to give you a left or right or horizontal shift. All right, very good. We're almost there. Have 2 more problems to look at. Write the equation of the absolute value function for each graph. Now, on the first slide, we talked about the parent function, and this is going to look so much like the parent function. Remember the parent function went up like this? from the vertex, it traveled at a rate of 1, 1. Well, this one is exactly the same, only it's going down. And so we can tell, we have to identify our vertex. Well, it's 0, 0. And so I remember the parent function is y is equal to the absolute value of x. So this is going to be the opposite of that, or y is equal to negative absolute value of x. So to get there, once again, I could think of, I put in 0 for x and then out comes y. That's a way to get there. And also just remember, because of the negative, then it's upside down. So if I was writing an equation, my equation would be this. Final answer. Now this one's going to be just a little bit more challenging. So the first thing we want to do is, and notice that it kind of stopped here, but I don't want that to confuse you. It does continue, it just stopped. And I don't know, again, it just goes up. It's going to be the same on the left as it is on the right. So let's identify our vertex. So I would be -1, -2, -3, and then down 1, 2. So I'm going to just write that here. -3, -2 is our vertex. That's step 1. And then we just use the equation. So I'm going to go ahead and write the equation for us. We like equations in algebra because they are a tool to get us to the right answer. Now that I know the vertex, then it's very simple. I'm just going to go back and I'm going to substitute into the equation. I notice that it's traveling at a rate of just 1, 1. That's going to be the parent function, or what an absolute value function does, what its tendency is. And so this is really a 1. I'm going to go ahead and just write that in for now, and then we'll just not do it the next time. Then I would have x minus, which is -3 here. That's going to be our x. And then we have a plus in our k value. Remember, this is hk. Our k value then would be -2. So I'm going to clean this up because it looks all kinds of nasty right now. Y is equal to x minus a -3. We're going to write that as x plus 3 because we know we never write two symbols beside each other, at least not when before we've simplified. And then plus a -2, that's going to be -2. So there, my friends, is our equation for this function. I hope that you've enjoyed your lesson on absolute value functions today.